Hello Year 11. In this video I want to work through the final question from your preliminary exam, which you will probably not be surprised to learn had the lowest success rate for the whole exam. So this was the question that the least people in your cohort got marks for, and I think that is not necessarily because this was the hardest question on the exam, but I think that low success rate is largely a result of this being the final question. And so for many of you, there just wasn't enough time to think carefully about what you needed to do. A common theme with trig identity proofs like this one is it can be very difficult to know where to begin. There's so many options, so many identities provided on your reference sheet, and it can be quite difficult to know which technique and which approach is going to lead me somewhere useful and which is just going to lead me down a totally unhelpful rabbit hole. And what I'd like to do as I talk through my thinking on this question is to try and share some of the ways you can find the hints in the question about what's going to be actually fruitful in terms of all the different results. And so if we start by looking at this result that we're trying to show, we've got sine of x plus sine of 3x plus sine of 5x plus sine of 7x, which I'll refer to that as the left-hand side. And then our right-hand side is 16 cos squared x times cos squared 2x times sine x. The first thing to note is that on the left-hand side we have the addition of terms, or all of them being sine terms. And on the right-hand side we have the product of terms, and those terms are a mix of sine and cosine. And so right away it can be helpful to think, well, I probably want to use one of the results that take me from products to sums, and I want to pick the particular result that has sums of only sine terms and products of a mix of sine and cosine. And so the result on your reference sheet that has that, and I'll just write it out here so we can refer to it, is that the sine of some angle A times the cosine of some other angle B is equal to a half times sine of A plus B plus the sine of A minus B. So notice this result has the sum of only sine terms, sine A plus B and sine A minus B, and it's being linked to the product of a sine term and a cosine term. So this should hopefully lead us somewhere useful. And in our result, notice that we don't have a half in front of anything on our left-hand side. It's just the pure sine terms. So it can be helpful to just do the slight rearrangement. In this case, multiply both sides by 2, and you get 2 sine A cosine B is the sine of A plus B plus the sine of A minus B. And that is what we're going to be working with. And it's also at this point worth noticing that in this reference sheet result, the term out the front of the items being multiplied is 2, whereas in our result the term out the front is 16. So that gives a bit of a very subtle clue that we're probably going to use this result multiple times. We're going to iterate through it enough times so that all of our 2's multiply together to get us to 16. So from here, this is maybe where the moment of creativity is required, but we have to think, how can I get from angles that have x and 3x and 5x and 7x into a result that only has x and 2x. And here, there's really no rule. I think it's really just a matter of exposure to enough of these kinds of questions to get good at what I'm about to do next. which is to notice that halfway between x and 3x is 2x. And so I can think of x as being 2x minus x, and I can think of 3x as being 2x plus x. And similarly with 5x and 7x, I can say halfway between those two is 6x, and I can think of 5x as being 6x minus x, and I can think of 7x as being 6x plus x. And through that little tweak in what I'm dealing with, I've now moved to only angles, inputs that are either x or some multiple of 2x. And so that's going to be where we begin. So I'm going to start by saying, let's say the left-hand side is equal to, and instead of sine of x, I'm going to write that as 2x minus x. And instead of 3x, I'm going to write that as sine 2x plus x. So I've linked those two terms where I highlighted the angle in yellow. They've now just been rewritten in this form. And then for the 5x and 7x, I'll do a similar thing, but instead of 5x, I'll write that as 6x minus x. And instead of 7x, I'll write that as 6x plus x. And so those are the two terms with the blue highlighted angles. And now that I've written it in that format, hopefully it's clearer to see the link between what we've got on our left-hand side and this product to sum result, which I've got as the 2 of sine A cos B equals sine A plus B plus sine A minus B. In our case, for the first two terms, effectively the A and B we can think of as A being the 2x and B being the x. So I've got the sine of A minus B plus the sine of A plus B, which is fundamentally the same as the result we're working with. So I can now say, well, those first two terms I could write as 2 times the sine of 2x, because A is equivalent to 2x, times the cosine of x, which is what B was. And so that deals with the first two terms, and I can do the exact same thing for the next two terms. For these, A would be 6x and B would be x. And again, we've got an A minus B and an A plus B. So I can use the same result. So plus 2 times the sine of 6x times the cosine of x. And from here, hopefully it's easy enough to notice that we've got a common factor in both of these terms of 2 cosine x. So I can bring those out the front. And what's remaining is sine of 2x plus sine of 6x. And it's worth noting that as I was marking your exams, several of you were able to get to this point. You were able to notice the link between all of those angles and this particular result and effectively write some variant of what I've got here. But what was less common, what less of you were able to then work out and realize, is that you can keep following that same process with that same result to eventually get to the right-hand side. And the key to it is essentially just repeating what I just did, but this time with what's inside the brackets. The sine of 2x plus the sine of 6x, I think about what's in the middle, 4x, and then I rewrite those terms. So instead of 2x, I'll write 4x minus 2x, and instead of 6x, I'll write 4x plus 2x. And you'll notice now I'm getting closer and closer to just having an expression that is only made up of sine and cosine terms with just x and 2x. So what I'll do in my next line of working, I'll just write this as equal to 2 cosine x, and in the brackets we'll have the sine of 4x minus 2x plus the sine of 4x plus 2x. And now I'm going to use the same result that I did before. So I can say that the sine of 4x minus 2x plus the sine of 4x plus 2x, that is going to be 2 times the sine of 4x times the cosine of 2x. And the 2 times 2 I can now write as 4, so I'm getting closer to the 16 that I need at the front. I've got a cosine of x, a cosine of 2x, and then a sine of 4x. And at this point, we now need to think, well, I've kind of run out of iterations of that result for the product to sum, because I no longer have sums anymore. I've only got a product of terms. 2 of my terms have the angles that I need. I have my cos of x and I have my cos of 2x. I've only got one of them though. I need another one of each of those to be multiplied. But for my sine term, I've got sine of 4x instead of x. So really the place to focus now is to think, how can I manipulate the sine of 4x to get that to only be in terms of sine of x. And the result that we can use, a slightly different result, we can think of the sine a plus b, that result, which is also on your reference sheet, as being equal to sine a cos b plus cos a sine b. And in this case, we can think of a and b as both being the same thing, which is 2x, because 4x is 2x plus 2x. So to make this really clear, I'll write what we've got as 4 times the cosine of x, the cosine of 2x, times the sine, and instead of 4x, I'm going to write 2x plus 2x, and I can treat that as a plus b. So a is 2x and b is 2x. So I'll have 4 times the cos of x times the cos of 2x times, and I'll just write now the result for sine of a plus b. We're going to use that. So it will be the sine of 2x times the cos of 2x plus the cos of 2x times the sine of 2x. And in this case, because both a and b were the same thing, they were both 2x, we effectively have 2 of the same term. Each of these terms are the same thing because the order of multiplying doesn't change anything. So I can actually write that as 4 cosine of x cosine of 2x times 2 of sine 2x cos 2x. And again, that's useful because I've now gotten even closer to 16 because 4 times 2 is 8. I've got my cos x still unchanged. But now I've got cos 2x times cos 2x, so I've got cos squared 2x, and then the sine 2x off to the end. And again, now I'm very close, and I can actually repeat that process that I just did, that result of sine a plus b. I can do that again over the sine of 2x, because again, our result needs sine of just x, not 2x. So I can think of 2x as x plus x. So I can say this is 8 cos of x cos squared of 2x times the sine of x plus x, and in exactly the same way we work through the result, and this will be times sine of x cos of x plus cos of x sine of x. And again, because they're essentially the same term, we've got two of them. So it's 8 cos x cos squared 2x times 2 sine x cos x. And now we get our final step. 8 times 2 is 16 as required. We've got cosine x times cosine x, which is cos squared x. We've still got our cos squared 2x. And then finally our sine x as the final term. And that's exactly the right-hand side that we were being asked to show. So by working through very carefully, we've essentially just used two of the results on our reference sheet to get to where we needed to get to. And there would be no expectation that you write out all the working that I've written out. I've only done that very meticulously and carefully because I'm explaining and walking through this question. But there are certainly many opportunities through that working where you could do what I've done in multiple steps. You could very safely do that in just one step. But hopefully in working through that in meticulous detail, you've been able to follow along and kind of see what I've been doing, and hopefully walk away from this video with the confidence to know that when you see questions like this, you've now got one example of the thinking process that can get you from what you're given to what result can help you. And as I mentioned earlier, there really is no shortcut to getting good at these. It's just simply a matter of exposing yourself to enough of a variety of them that you start to notice patterns in the techniques that are useful versus those that just send you down rabbit holes. So hopefully seeing this video has helped you, even if only a little bit, on your journey to getting good at these questions. But please know that often it's not the case that the algebra is particularly difficult. Once you're on the right path, you can get these marks.